Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sos Ugobela Wemet. And without any further ado, let's look at this question that we have here. Okay, so we have question 5. It says, given that sine alpha is equal to negative 4 over 5, and alpha is an element of 90 degrees all the way to 270 degrees, which is giving us an option to draw either in the second quadrant or the third quadrant. It says, without using a calculator, determine the value of each of the following in its simplest form. So we must determine all of this, right? So we know that without the use of a calculator, we must make use of the diagram. So let's just try to indicate our diagram here. And then there we go. So we have our 4 quadrants there. But now we know that we do not draw on all of those quadrants. We must choose based on the restriction that we are given here. And also the fact that our sign here is a negative, right? So between 0, this is 0, 90, 180, 270, and then 360. Now we can see between 90 to 270, the quadrants that are included there are the second and the third quadrant. But where do we find sign being negative between these two quadrants? It is obviously in the third quadrant, because in the second quadrant, we know that sign is positive according to cast, right? So sign is positive in the second quadrant. That means it has to be negative in the third quadrant. So this is where we would have our right angle triangle. So we just close off here to form a right angle triangle. And then now, considering that we are working with sine, if we have to consider SOHCAHTOA, we know that sine is opposite over hypotenuse. If our alpha is here, then the opposite side is negative 4 and the hypotenuse side is positive 5. Your hypotenuse should always be a positive. Now we are only left with getting our value for x here. So how do we do that? We're just going to say x squared is equal to r squared minus y squared. So this will give us 5 squared minus a negative 4 squared. So punching all this in your calculator, you have 9. Okay, so they said without the use of a calculator, then here we know this is plus or minus square root of 9. But then considering that we have drawn this in the negative x-axis, we know that our x should come out as negative 3. So we have negative 3 here. Now, once you have filled out everything in your Cartesian plane, then that means you are ready to answer the questions. So let's get to this one. 5.1.1, we are given the negative angle for sine, which we know negative angle for sine is always negative sine, right? So negative sine alpha. We have the value of sine alpha though, so we can say this will be negative, and then we have negative 4 over 5. So negative and negative is positive. So our value is 4 over 5, just like that. Then 5.1.2, we have cos alpha, but then considering this is adjacent over hypotenuse, which is the same as x over r. Our adjacent is this side, our hypotenuse is that. So our cos alpha will be equals to negative 3 over 5, right? So for 2 marks, that's what you do, and this also for 2 marks, right? But then let's get to 5.1.3. Now, it's starting to get a little bit tricky there. Okay, so now let's just erase this part here. So I want you to consider this, guys. Looking at this, we can see that this is similar to what we have here. So this is a compound angle. A compound angle for sine, which goes sine A minus B is equals to sine A cos B minus cos A sine B. This is in the same format, right? So that means we would have to solve that using our compound angles. So how do we break down this one? This becomes sine alpha and then cos 45 degrees minus cos alpha and then sine 45 degrees, right? So what is our sine alpha? According to our diagram here, or the solution that we have here, it's negative 4 over 5. Then what is cos 45? If we are to use the right angle for the special angles, we know for 45, we have 45 here, and then 45 here, then it goes 1, 1, and then root 2, right? So this is given from your notes. I did not come with it from the top of my head. It is there, right, on your notes for trigonometry, right? So cos 45 would be adjacent of a hypotenuse, which is 1 over root 2. Now, we know that you should not use a calculator for this one, because if you press it in your calculator, it gives you root 2 over 2. Then what is cos alpha? Our cos alpha we have calculated, it's negative 3 over 5. And then again, our sine 45, it's opposite of a hypotenuse, so it will still be 1 over root 2, right? So we know cos 45 is equal to sine 45. Then if we are calculating here, this multiplied by that will give us negative 4 over 5 root 2. And then if you multiply this, this is plus 3 over 5 and then root 2. Now calculating this, negative 4 plus 3, that's negative 1 over 5 root 2. So I'm just going to leave it like that because I'm not using a calculator. So, okay, 3 marks, you've got it like that. Then 5.2 says, consider the identity. We are given this identity. So we know with this one, we must prove that the left-hand side will be equal to the right-hand side. So always the trick with this one is that you work from the side that is much more complicated, and then you solve it to be the same as the easier side. Obviously, that makes practical sense, because if you try to solve this one so that it looks like that, you would obviously fail. Then this is 8 sine, and then look at this. This is 180 minus x. So if we can just take a little while to just remind ourselves of the reduction formulas. In the first quadrant, we have the reduction formulae 90 minus x. In the second quadrant, we have 90 plus x and also 180 minus x. Then in the third quadrant, we have only 180 plus x. So we know we are not using 270 minus x in your level. Then IV, quadrant number 4, we only have 360 minus x. So again, here we are not using 270 plus x. Then this is all that we have. Okay, we can also include that we have 360 plus x. If it says 360 plus x, it still falls within the first quadrant. Then to prove this identity now, we're going to say, how is sine in the second quadrant? So we know that sine in the second quadrant, according to cast, is positive, right? So this is 8 sine x. But then we know if it's written like this, this is also another form to show a negative angle. So all we have to do here is just add by 360 inside here, then we'll be left with this x. So this is cos x. So every time you are just given it in a weird way, say maybe x minus 180 degrees, then all you do is just add 360, because we are not used to this notation. The correct notation is having it like this, 180 plus x or 180 minus x. So every time it's like this, then you have to add 360 degrees. But do not do it if it's like this. If it's like this, guys, this is not a negative angle. You can just rearrange this. You can just write it like this, 180 plus x. It's the same thing, right? So this is a negative angle, but this one is not a negative angle. So there would be no need to add 360 here. I hope that makes sense. Then over sine squared x, then this here is a cofunction. It becomes minus cos squared x, right? So let's write here, we are working from the left-hand side. Now, if we had to manipulate this one, I want to show you something here. I'm just going to write my 8 here as 4 outside, and then in bracket, this is 2 sine x, and then cos x, right? So I want to show you why I'm doing that. Then even from this one, let me factor out the negative. If I factor out the negative, I want to start with cos. I will say cos squared x and then minus sine squared x. If you can check here, I did not change anything. the cos squared x is still negative, because if I multiply inside with this -1, it will still give me negative cos squared x. Now here I said negative sine squared x, but if I multiply inside with this negative, I will still get positive sine squared x. So I just manipulated, I did not change anything, right? It is allowed in maths to manipulate and not to change anything. This is 4, but then remember looking at this one, right? So if we go back here on our reduction formulae and our trig identities, we can see that this one here, it's similar to what we have here. Sine 2x is equal to 2 sine x cos x. So all of this is a trig identity which can be just written in one trigonometric ratio of sine 2x, a double angle, right? But then look at this one as well. Cos squared x minus sine squared x. This is also a double angle of cos. This is cos 2x, right? Pardon the pun there. This is cos 2x, so it's that. So that means I can just reduce these ones to sine 2x, and then also down here I have the negative outside, and this would be cos 2x. Now 4 divided by -1 is -4. But look at this, sine 2x over cos 2x. We know that every time we have cos x over, sine x over cos x, this will give us tan x. That means if we have sine 2x over cos 2x, it should give us tan 2x. That's how it goes. So this here should give us tan 2x. But then look at this. Look at the magic. So we can then say, therefore, the left-hand side is equals to the right-hand side. We have proven our identity. So that's all you needed to do, guys. That's how you were supposed to tackle that question. Then let's move to 5.2.2. So it says, for which values of x in the interval, x is an element of 0 all the way to 180 degrees, will the identity be undefined? Now note this, guys. Every time we are told about the identity being undefined, we know that if we have anything in fraction form like this, a over b, then in order for this to be undefined, all you have to ensure here is that your b will be equal to 0. So which is why every time they tell you of rational numbers, they always emphasize that your b should not be equals to 0. Why? Because if your denominator here is a 0, then the whole expression is undefined. So in order to make this identity to be undefined, we would have to ensure that our denominator is equals to 0. So that means in solving that, all we have to do is just take the expression here in the denominator and then equate it to 0, right? So that's what you do. Then we have sine squared x. This is minus cos squared x, and then equal to 0. Now we can take this and then equate it over. So here I'm just trying to show you the calculation. This is only 2 marks, so that means you don't have to go through all this trouble, right? Then at this point, I can divide both sides by cos squared x, and then over cos squared x. But then why am I dividing by cos squared x and not dividing by sine squared x? I'm trying to form the trig ratio here at tan. So I'm trying to use the identities. So I know that this will become tan squared x, which is equals to 1. Now, if I were to solve this one, square root, and then this will give me tan x is equals to 1, then my x would be, so I know if I do this, this is x is equals to 45 degrees, right? But then considering that I'm dealing with sine and that sine is positive there, I would have to also use the fact that in the second quadrant sine is positive. So I will say 180 degrees minus my reference angle of 45. So I get my value as 135 degrees, meaning the two values for which the identity will be undefined is when x is equals to 45 degrees and or also when x is equals to 135 degrees. So these are the two values for which the interval will be undefined. So even if you can go here and try to substitute 45, then you will see that this whole expression will give you 0. Also, if you try to substitute 135 in the place of x, you would see that this expression here in the denominator gives you 0. So remember, you only test with the denominator here. We know that if the denominator is 0, then the expression is undefined. So you have x is 45 degrees or x is equal to 135 degrees, right? So there's a trial and error method of doing that. But then here I was just trying to show you in terms of the calculation, how you would have obtained that. Now you can just do the calculation by the side and just come with your solutions here. So you do not need to show all those calculations because it's only 2 marks. Then 5.3, it says determine the general solution of cos 2 theta plus 4 sine squared theta minus 5 sine theta minus 4. Now, to be successful with answering this question, you need to always check what's in the middle term, right? Check the trig ratio on the middle term. So this will help you in terms of changing your trig identity here or changing your double angle. Remember, the cos 2 theta can break down in 3 different ways. Now, it's a matter of deciding which one will be more suitable for the expression that you are given here. So looking at this, we can see that we can break it down in this form, that form, or that form. But then if I were to look at my middle term, I can see that my middle terms are sine. So it is best to just work with one trig ratio. So I will have to break it down in terms of 1 minus 2 sine squared x, right? So it's better that way because I ensure that I only work with one trig ratio, which is the fastest way to success with this question. Then now solving my cos 2 theta, this will be 1 minus 2 sine squared theta, and then plus 4 sine squared theta minus 5 sine theta, and then minus 4 is equals to 0. So hoping that you can see that. Then these are like terms here. These are like terms. So I have 1 plus 2 sine squared theta. So negative 2 plus 4, it's positive 2. Then minus 5 sine theta minus 4. So let me fix my 5 here. It looks like an S. So, okay. Then equal to 0. Then this is 2 sine squared theta minus 5 sine theta, and then 1 minus 4, that's minus 3 equal to 0. So if I were to factorize this, this comes out as 2 sine theta plus 1, and then here I have sine theta minus 3, right, is equals to 0. So looking at this, you can see that this still falls within this. This is the same as you having this, and then they say factorize that. So do not be intimidated by the fact that now you have the trig ratios there. This still operates the same way. You can still put this in your quadratic formula if you cannot factorize. Then your sine theta here is equals to negative 1 over 2, but your sine theta here is equals to positive 3. Now we know that once your value here is greater than positive 1 or less than negative 1, then here you just mainly say that there is no solution, so it's not applicable. Even if you are trying to calculate here the angle, you will just find that it says maths error. So here you just say not applicable. Then you have to work with this one. But then note here that every time you are working with this one, you have to consider that if you are looking for the reference angle, you do not include the negative sign. The negative sign is only telling you the quadrants where you need to find your solutions. I hope it makes sense. Then to find your reference angle, all you have to do is say sine theta and then write that value there as a positive and then try to calculate now. So note that because a lot of time you make mistakes here. Then this is theta is equals to 30 degrees. So you immediately label this as your reference angle. Now come back here. This is negative. So that means I will find my solution where sine is negative. So the first quadrant where sine is negative is the third quadrant. So in the third quadrant, we have sine being negative. So the reduction formula in the third quadrant goes theta is equals to 180 degrees plus the reference angle, so plus 30 degrees, then plus K360. So my solution is 210 degrees plus K360 degrees, where K is an element of integers. But again, your sign is negative in the fourth quadrant. So we have theta is equals to 360 degrees minus the reference angle of 30, and then we have plus K360 degrees. Now, this will give us 330 degrees plus K360 degrees, where K is an element of integers, right? So that's all we have there. We have our general solutions like that. So that's how you were supposed to tackle that question. So you can see those are very lucrative marks. Then we have 22 marks all in the bag, guys. So make sure that you practice a lot when it comes to trig functions, because if you don't know these general solutions, if you cannot prove identities, if you cannot solve to one trigonometric ratio, you're going to be losing marks, and then you'll be losing big chunks of marks. So you see these ones are just 2, 3, but then with the general solutions, the identities, and then having to simplify to one trigonometric ratio, it is a very large mark. So you find it 6 marks, 7 marks, 8 marks sometimes. So you really need to put in the effort there. Okay, so that's it for our lesson today. Please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.